welcome to week 10 of geometry. We are in the week of March 14th, so a happy early St. Patrick's Day to you. This week we've got a lot of stuff we're going to go over in this recording, so I'm not going to do a warm-up problem, but instead I just want to remind you to make sure you've got a math notebook out and you're ready to take good notes. Remember, you do need to be taking notes as you watch this recording. We're going to cover a lot of important stuff that will be very helpful when you go to do this week's assignment, so please make sure you are taking notes. You might see some of the problems that we do today in the recording on your assignments this week, so make sure you do write down notes. So if you don't have your math notebook out, go ahead and grab it now, and then we're going to go ahead and get going. So this week we are moving on to Unit 7, a fresh new unit. So you're going to take the Unit 7 pretest. Remember, this is just for you to get a look at what you're going to be learning in Unit 7. So full credit for just completing it, no matter how you do. And then we're going to go on and complete Session 1, which is about areas of triangles and quadrilaterals. And then we're going to move on to Session 2 about circles and polygons. So let's get going. All right, so Session 1 is about triangles. And I did want to take some time to just review the formula to find the area of a triangle, and I think this will get you back into thinking about how to find the area of objects, which is a lot about what Unit 7 is all about. So this will get us back to thinking about finding the area of different objects. So the first formula is the area of triangles. And I know this is going to look familiar to you. I know you've seen this before. So the area of a triangle is 1/2 the base times the height. So I just wanted to go over what the base is. So the base is the bottom of your triangle. And then the height, this is really what I wanted to focus on. The height needs to make a right angle. It must form a right angle with the base. So your height has to form a right angle with the base. So sometimes your height might not necessarily be a line on your triangle, such as this one right here in blue. So the height is going to be the measurement from the top of our triangle down to the bottom, where it forms a right angle with the base. So the height would not be this side here or this side here. The height needs to form a right angle with the base. So again, sometimes your height might not be one of the actual legs. We can draw in the height from the vertex down to where it creates a right angle with the base. So again, here on this triangle, we see that this leg and this leg are not the height. Instead, the height is drawn down from the vertex to create that right angle with the base. So that's what's really important about our height. The height must form a right angle with the base. All right, so let's take a look at this triangle, and we want to find the area of this triangle. So if you feel like you can do this already and you want to try this on your own, go ahead and click pause now and try and find the area of this triangle. And then when you're ready to check your work with mine, go ahead and click play. All right, so we know the area is 1/2 base times height. Or you can write it as the area is base times height divided by 2. Whichever formula, they mean the same thing, but whatever kind of makes more sense in your head, you can use either form. You're going to get the same answer. They mean the same thing. So what is the base? What is the base? So right here, this is the base. The base is equal to 12 inches. What about the height? What is the height? Is it 10 inches? No, because we need to have that right angle. The height must form a right angle with the base. So the height is that measurement, that 8 inches. So we can go ahead now and plug in our values. I'm just going to use this formula right here. The base is 12, and the height is 8, and we'll multiply those two together and divide that by 2. So we're going to multiply those two measurements, the 12 times the 18, or I'm sorry, 12 times 8. And I get 96, and then I'm going to divide 96 by 2, and I get 48. So if you put down 48 as your final answer for the area, would I give you full credit? What do you think? No, we must include units. Whenever we're talking about area, we need to include our units. So because we were working with inches, I'm going to do inches squared. So units for area is always units squared. So this is really important because if you don't put units in, I'm going to be taking off credit. So you must put units squared for area. So units for area is always units squared, whether it be inches squared, feet squared, centimeters squared, whatever units you're using, you're going to square those. So make sure that you write that down in your notes that you're going to square your units. All right, moving on to the next slide. So parallelograms is the area to find parallelograms is just base times height. And the same thing is true where the height you must, whoops, not a capital B, the height must form a right angle. Again, the height must form a right angle with the base. So just like with triangles, the height has to form a right angle with the base in order to be the height. And then it's just base times height. So let's see if we can use what we know is the formula to find the area of a parallelogram to answer this question. So the question asks us to find the base. So find the base of a parallelogram if the area is 96 inches squared. Notice their angle or their units squared, and the height is 8 inches. So again, let's look at this question and write down what we're given. So it says the area equals 96 inches squared, and the height is 8 inches, and we need to find the base. We don't know the base. So let's use the formula for area of a parallelogram. Area equals base times height. And let's plug in the information we know and what we're trying to find. So I'm going to put x as b, or actually we can leave it as, let's just leave it as b. We don't need to, it already has a variable. So the area is 96 inches, so I'm going to substitute in 96 for a. We don't know the base, that's what we're trying to figure out, so I'm going to leave it as b. And then the height is 8 inches, so I'm going to substitute in 8 for height. So remember, b is being multiplied by h, so b is being multiplied by 8. So to get b alone, how do I do that? How do I get b alone? I do the opposite of multiplying, which is dividing. So I'm going to divide each side by 8. And then one step away from finding our answer, 96 divided by 8 is 12. So 12 equals the base. So I would say, remember, I always want to put in my units of measurement. So 12 inches equals the base, which would be answer C. I'm going to go on to the next slide, so if you need more time here, go ahead and click pause. And just a heads up, you're going to see lots of questions like this week where you're given the area and you'll be given like the height or the base, and then you need to find either the height or the base, whatever's missing. You'll have to do that like with triangles and all the other objects and figures that we're learning about this week. So this is a very typical type of question that you'll need to know how to do for this week. So just first start by writing down what's given and what you're trying to find. Always start with writing down the general formula of whatever figure you're working with, and then start substituting underneath the given information. And that's keeping yourself organized, and you can't go wrong that way. All right, so moving on. All right, so here we've got a parallelogram, and parallelogram, remember, is when you've got two sets of opposite sides that are parallel. That's what a parallelogram is. Both sets of opposite sides are parallel. That makes it a parallelogram. And that's what we were just looking at here. Both of our opposite sides were parallel. All right, so it says find the perimeter. Okay. We also know with parallelograms, the opposite sides are congruent. So that's one thing that we know about parallelograms, so the opposite sides are congruent. And remember, we learned this back in the beginning of the year. If I have one tick and one tick here, that means both those sides are congruent. And if I have two ticks here and two ticks here, that means those two sides are congruent. But with a parallelogram, one of the properties is that the opposite sides are parallel. The other property is that the opposite sides are congruent. So knowing that property, we know the opposite sides are congruent. So I know if this side is x plus 4, this side must be x plus 4 as well. If this side is x minus 1, I know this side must also be x minus 1. And if we need to find the perimeter, remember the perimeter is just if you add up all the sides together, that's your perimeter. So let's do that. Just because it's got variables, don't let that confuse you. So let's just write it down as is. So we're going to do x plus 4 plus x plus 4. You don't really need the parentheses. I'm going to actually take those out. And then we've got x minus 1 plus x minus 1. We don't need those parentheses. We can take those parentheses out. If you want them in there, that's fine. You can keep them in, but I'm just going to go ahead and take them out. And then I'm going to add all my like terms together. So how many x's do I have? 1, 2, 3, 4. Those are like terms. They're all x's. So I've got 4 x's. And then my other like terms are my whole numbers there. So we're going to add those together. 4 plus 4 is 8. Minus 1 is 7. Minus another 1 is 6. So we had 8 minus 1, which is plus 6. And that would be my final answer. Now, of course, I would want to put inches in there because we're talking about perimeter. So that would be my final answer. It's really just all about adding our like terms together here. And you'll see questions similar to that on this week's assignments. All right, so rhombuses and kites. In session 1. So rhombuses and kites, they look very similar, don't they? So here is an image of a rhombus and a kite. So they look very similar. They're almost both kind of a diamond shaped, but there is some differences. So let's look at the rhombus first. So here I see one tick on this leg, one tick on this leg, and one tick on this leg, and one tick on this leg. What does that tell us about all the sides of a rhombus? It tells us that all sides are congruent, right? All sides are congruent in a rhombus. What about looking over here at the kite? So let's look at the ticks that we have going on our kite. So here I see that there's 2 ticks on this leg and 2 ticks on this leg. But then looking at our other legs, I see that there's 3 here and 3 here. So not all of our legs are congruent, right? So in our kite, we've got 2 sets of congruent legs. So in our kite, a little bit different. We've got 2 sets of congruent sides. These 2 sides are congruent and these 2 sides are congruent. So they are different. They are different. And then I've got the formula to find the area of a rhombus or a kite. So even though the figures are not they're not the same thing. Rhombuses are different than kites. They do look similar. And the area to find both is the same actually. So the area to find the formula is right here. And this formula we use to find the area of both rhombuses and kites. So the area is 1/2. Oh, I've got a D1 and D2. What does that mean? So D1 and D2 is talking about diagonals. So D1 and D2 mean diagonal. So whenever you see a D, that means diagonals. And diagonals, if we remember, is when we start at one vertex and we go directly opposite to another vertex in the figure. So here's another diagonal going from one vertex to the other. So to find the area of a rhombus or a kite, we're just going to take 1/2 the first diagonal times the length of the other diagonal. That's it. That's how we find the area of a kite or a rhombus. We're going to go on to the next slide. So make sure you take good notes before you move on. If you need to, you can click pause. All right, so here's a question where we're going to use the area of that we just learned, area of rhombuses and kites. It says find the missing diagonal. So find, it says the missing diagonal. So we know we're trying to find one of our D variables of a kite with an area. So we're given the area. The area is 112 square meters. If the other diagonal is 16. So let's write down our general formula. We always want to start by writing down just the general formula we're working with. So the area equals our diagonals multiplied times each other divided by 2. Which is the same thing as saying 1/2 D1 times D2. You can write it either way, whatever you're more comfortable with. So I know the area is 112, we're given that, and one of the diagonals is 16, and we need to find the other diagonal. So now we've got one variable that we're solving for, our D2, our second diagonal. So how do we solve for that? So remember, we always want to get rid of our denominators first. That's the first step, is we always want to get rid of anything in our denominator. So let's get rid of this 2. So 16 D2 is being divided by 2. So what's the opposite of dividing? Multiplying. So I'm going to multiply both sides by 2. And that's going to cancel out this 2 on the right side of our equation. So 2 times 112. I'm going to do that. 2 times 112. Is 224, and that's going to be equal to 16 times D2, our second diagonal. So we want to solve for D. We want to get D all alone. So right now D2 is being multiplied by 16, so the opposite of dividing or multiplying is dividing. So I'm going to divide each side by 16. And 224 divided by 16, we are almost done, is 14. So the length of our second diagonal is 14. And of course, if we were writing our answers, we would want to say 14 inches. We want to include our units of measurement. Oops, I don't know why I said inches. It's actually meters. It would be meters in this case. So let's get rid of the inches and replace that with meters. All right, going on to the next slide. So if you need more time, go ahead and click pause. And we're going to go right into regular polygons. So a regular polygon is we can have any number of sides, 3, 4, 5, 6. It's got to be greater than 3 sides. But what's important for it to be regular is that all the sides must be congruent. So in a regular polygon, all sides are congruent. That's what makes it a regular polygon, is that all sides have to be congruent. Any side, we can have any number of sides as long as it's 3 or greater. So parts of a regular polygon. So now we're getting into session 2. So we've got a radius, which I know you guys have heard that term before, and a radius is when we start from the center and we go out to any side. So the radius is just starting at the center, and the line will go out to the side. So that's what a radius is. The center, again, is the very center of our figure. And apothem. Apothem is something new. And I guess I should, before I talk about apothem, make sure that we're good with the fact that this polygon is actually the outside here. I'm highlighting it in purple. So the circle was just drawn around that to remind us of what a radius is. So kind of ignore the fact that we've got a circle around there. I almost wish I could take that circle off right now. It kind of shouldn't be there, that circle. It was just to help us see where the center is. But so the apothegm, it's a funny word to say, I think. So let's write down what an apothegm is, because this is probably a new word for most of you. So an apothegm is a line segment, a line from the center of our figure. It's a line from the center of any regular polygon, and it's forms a right angle with the base. I'm not going to say at, and it forms a right angle with a base. Or I should say side. So it's an apothegm is a line from the center that goes out from the center and must form a right angle with the base. So that's what an apothegm is. It forms a right angle with the base, and that's what an apothegm is. It's a line out from the center, and it must form a right angle with any side or any base of your any side. I guess I should be saying side of your regular polygon. So that is what an apothegm is. It forms a right angle with the sides. So we can draw in another apothegm, start at the center, and it must form a right angle. So we've got several apothegms in this regular polygon. So kind of similar to what we were talking about heights with our parallelograms and triangles, that they share that idea that they have to form a right angle with the side that they're intersecting. I'm going to go on to the next slide, and we are going to write down the area to find the area of any regular polygon. It doesn't matter how many sides, the area of a regular polygon, no matter how many sides, is right here. 1/2 A times capital P. So it's important now that we know what these variables represent. So when we've got the formula, area equals 1/2 A times capital P. So A equals the apothegm. And P, capital P, represents the perimeter of the polygon. So write down the formula as well as what A and P represent in that formula. And then we're going to use it. We're going to apply it in the next slide here. All right, so here is a regular polygon. We've got a 1, 2, 3, 4, 5-sided polygon, and we want to find the area of that polygon. We're given some information. The length of one of our sides is 8 inches. And we've got this measurement right here that forms a right angle with the side, which is 5.5 inches. So what is this measurement that starts from the center and intersects the side at a right angle? What does 5.5 represent? That is our apothegm. That represents our apothegm. And then we've got a side length of 8 inches. So let's write down our formula. If we look, remember 1/2 A times P. Whoops, I forgot my 1/2. 1/2 A times P. All right, that's how we find the area. 1/2, what is the A? The apothegm. That's given, that's 5.5. What about the perimeter? Am I given the perimeter? I'm not given the perimeter straight up, but I do know the length of one of my sides is 8 inches. And how many sides are there? 1, 2, 3, 4. There's 5 sides. So that means the perimeter is going to be equal to 8 times 5. 8 times 5 is 40. So the perimeter is 40. Now I can just do the math. 5.5 times 40 is 220, and then I'm going to take 1/2 of 220. So 220 divided by 2 is 110. Am I done if I just said area equals 120 or 110? I'm sorry. Would I give you full credit? Nope. We need that inches squared in there because we have to have our units of measurement. Going on to the next slide. If you need more time, go ahead and click pause. I do want to do one more, work through one more concept with you before we call it quits for the recording. And that is, many times you're not given the apothem length. And you still need to find the area. So I'm going to just show you how you can find the length of the apothem if you're given a side length in your regular polygon. So if you are given a side length and you need to find the apothem, this is what you're going to do. So here, I've got a regular polygon with 1, 2, 3, 4, 5, 6 sides, and we're given the side length is 10 centimeters, and we want to find the apothem. So what I've done is, if you look over here now, I've focused in on this triangle that we have if we draw in our radiuses. If we draw in 2 radiuses, we've got this triangle, and the apothem is what we have in the middle there. So here's our apothem right here. Forms a right angle with the side of our polygon. So in order to find the apothem, we are going to use the fact that if we, this angle measurement right here, if we've got this right triangle right here, the angle measurement right there is always going to be represented by 180 divided by n. N equals the number of sides of our polygon. So once we have that angle measurement, we can then use one of our trig ratios, SOHCAHTOA or TOA, to help us find the height. The height is our x. So we're kind of focusing on this right angle. Oops, I wanted it to be yellow. So we've got this right triangle here that we're working with, and when we know when we have right triangles, we can use SOHCAHTOA. So let's redraw our right triangle down here, and let's see what we can figure out. So this angle measurement is always represented by 180 divided by n. So I know that we've got 180, how many sides? We've got 6 sides, so 180 divided by 6 is 30. So this angle is 30 degrees. What is the length from here to here of my triangle? Well, if the entire side is 10, half of 10 is going to be 5. And we need to find this height. We're trying to find our apothem. So I can set up a trig ratio. So if this is my reference angle, the 30 degrees, I know the opposite side, and I'm trying to find the adjacent side. So I've got the opposite side, which is 5, and I'm trying to find the adjacent. Opposite and adjacent, that means we're going to use the tangent, TOA. So tangent 30 equals opposite over the adjacent. And then to solve for x, remember we can multiply both sides times x. This is a review, so it would be tangent x times tangent 30 equals 5. Divide each side by tangent 30. This is review from last semester. So x is going to equal 5 divided by tangent 30. And I get 8.6, rounded up to 8.7 actually. All right, so that means the apothem is going to be equal to 8.7. So the apothem height would be 8.7. So there's going to be several problems this week where in order to find the area of a regular polygon, you're going to need to calculate the apothem. The apothem is not going to be given, and you need to, given a side length, you need to find the apothem. And again, I want you to write this down in your math notebook right now. is if you're given a side length and the apothem is that right angle that the side that forms a right angle with the base, we can use that idea of a right triangle and trig ratios to help us find the length of the apothem. Now, to find this angle right here, to use a trig ratio, it's always going to be 180 divided by the number of sides. So write that down. To find this angle right here, it's going to be 180 divided by the number of sides. And that's going to be helpful, is knowing how to find that angle measurement, then that you can use your trig ratio. So write that down in your math notebook. Go ahead and click pause. And then we're going to move on and finish up. All right, so we're ready for our key phrase question. And this week we looked at how we can find the area of a regular polygon, which is A equals 1/2 apothem times the perimeter. And we talked about sometimes we'll be given just our side length and we need to find our apothem. And we talked about how we can draw in a right triangle that will allow us to figure out the apothem length based on just given a side length. And I taught you a trick of how you can find this angle measurement. So what is the formula that we use to find this angle measurement? So how do we find this angle measurement? That is your key phrase question. How do you find this angle? So what was the little trick that I gave you that will allow you to figure out this angle measurement? And then you can go out and use a trig ratio to finish out it. But the question is that I want you to focus is on how do we find this angle measurement? What was that little formula, that trick that I gave you to find that angle measurement? And that's it. So let me know if you have any questions or you need any help with this week's assignments.